stuff. So we're picking up here. Oh, but before we pick up here, are there any questions about these announcements? I'm kind of thinking everybody here has turned in a project, at least. I have a little bit of a cold. I think hopefully it won't stay very long. But if you have another project to turn in, it needs to be done by the end of today. I have a second one. And better get your taxes in too, don't forget. That's what we're going to do this weekend. Goodness gracious, it just does not want to start. Well, anyway, so on still talking about, oh no, we're just now starting to talk about tornadoes. So this just does not want to work. Oh, maybe that's why. All right. Whew, goodness. So one of the things that can be associated with cumulonimbus clouds are tornadoes. We talked about kind of a simple air mass thunderstorm cell, and then we talked about supercells, and honestly, supercells are more likely to give you tornadoes than just the regular ones. Okay. I think this is a video. Let's see what this does for us. Yeah, it's gonna work. It's gonna work. So the tornado actually is, how do I say? It has an L in the center of the tornado, like at the Earth's surface. It's a low pressure. And if you were to look at, and it's hard to study tornadoes because they're so short-lived. You don't really know where they're going to be. But if you were to look at the vortex of a tornado and kind of go out from there, you would see very tight isobars, that strong wind. Okay, so tornadoes, the video we saw talked about an EF or an F5, right? Some of you guys know that's the strongest tornado. The weaker tornadoes are more likely to occur. There's a lot more weaker tornadoes than F5s. But they last different amounts of time, okay? Notice that, I think it said, was it 320? 318 miles per hour, okay? In F5, like, dang. So tornadoes can kind of look different. Isn't this ironic? There's the whole rainbow, right? The sun must be over here, and basically you have rain, and there's a tornado behind it. They take on kind of different shapes. Probably this one is kind of more like, I think they call a wedge shape. I don't know, tornado. And then this is a rope shape tornado. I'm going to introduce a term called just a funnel cloud. And a funnel cloud is basically a tornado that didn't hit the ground. Okay? So basically you have, if you're looking down, it's going to be counterclockwise because of that low. So you have counterclockwise wind running around there. So figure from your textbook that has some interesting things. The world's deadliest tornado, we're going to see a map here in a minute of where tornadoes are, but the deadliest tornado was not in North America. Okay, it was in Bangladesh. And you can see how many people it killed and injured. In the United States, the deadliest single tornado was in 1925. Don't you think between 1925 and now we have a better warning system? So I think that's kind of why we don't have a lot of people being killed as much. We're going to talk about, and you've seen this before, where sometimes it's not just a single tornado here and there. Like last night, it was a tornado watch. Somebody said that actually there was a warning for a county in, I don't know if it's Illinois or Iowa.
It was Audrain County.
It was which county?
Audrain.
Okay.
So they're talking about on the news last night.
Okay. Is that in Iowa?
I believe it's in Illinois.
Missouri? Illinois, okay. So, of course, a warning means they saw one. A watch just means, the atmosphere is pretty unstable. You could get thunderstorm cells and the tornadoes that come with them. But a lot of times they come in, like, a lot of them, and we call that an outbreak, a tornado outbreak. So these are both, the biggest 24-hour outbreak spawned 147 tornadoes. So basically that's just that crazy chunk of air that's unstable giving multiple thunderstorm cells, and those thunderstorm cells spawning tornadoes. The widest one is 2.5 miles. Okay, usually they don't go that wide, but that's pretty darn wide. Notice that that was an F4. Okay, you may be used to calling F4, F5, and the E just means enhanced Fujita scale. So EF. the greatest recorded tornadic wind. Actually, check this out. The video we saw said 318. This says 302 miles per hour. So that one would have superseded this one. Longest tornado transport. We're going to see this statistic here in a minute. But basically, a personal check was relocated 223 miles within the tornado. But that means that the tornado went that far? Like, really? So I just think that's cool. So kind of like the premise of the movie Twister. How many people in here have seen Twister? Yeah. Okay, she was trying to gather some hardcore science data. And they're hard to know where and when they're going to be. One of the things I think is cool is, and I don't know if it's an old project called some sort of intercept. Maybe you're familiar with it. There's been documentaries out there. But basically they have a tank, a vehicle that's like a tank. And the tank is supposed to go into basically the eye of or the vortex.
Things that go out so it can like
Yeah.
tag to the ground so it can get right.
Exactly, and it's chasing tornadoes. So if you're chasing tornadoes, these are the places you might look. A cold front especially, or a dry line, can give you basically a series, we talked about this the other day, a series of thunderstorms. Again, not all thunderstorms give you tornadoes, okay? And we'll talk more about kind of what ingredients gives you tornadoes. We talked about, aside from squall lines, those are those blobby mesoscale convective complexes. Supercells versus an ordinary cell. To me, supercells are where your culprit is for giving you hail, tornadoes. And on the next chapter, when we talk about hurricanes, hurricane is the generic name, or hurricane is the specific name for tropical cyclones. So tropical cyclones is generic. So those are hurricanes. So when do they form? When are you going to get that instability, right? Well, kind of the hard part of your days, 3 to 8 p.m. If you are going to chase tornadoes, it's really dangerous to chase them at nighttime, because your best bet to see them is basically lightning lighting them up. So thou shalt not chase tornadoes for this class anyway. So here's kind of some destruction that was left by tornadoes. This actually is part of an outbreak of tornadoes. 84 tornadoes on this day, part of that same weather system. And the one thing about tornadoes versus hurricanes that we're going to talk about on Monday is that tornadoes are classified after the fact. So kind of think of an insurance adjuster going out there and gauging the damage that was done, the wind speed, and then associating that back to, was it EF5, EF4, 3, 2, 1, EF0, right? So a full-fledged tornado is different than a funnel cloud, in that a funnel cloud doesn't reach the ground. But the reason, and there's a video I showed last night, and we might see it next week, we'll see. But tornadoes can be dangerous because they can be invisible. Like, really? Well, moving air is invisible. And the thing that makes them visible is kind of explained here. Either they're kind of kicking up cows or picking up debris or something like that, okay, that makes them visible. Or we have basically water vapor condensing. So it can be very dangerous. And I think a video I'm going to show you is I want to show you here in a minute, will show us this, that it's quite possible that with the same major tornado, you can have multiple kind of ropey sort of sucky-uppy things called vortices, suction vortices. Yep. So you have your main tornado, and then you kind of have this assortment of other stuff coming up. I'm going to show you a figure here in a minute of what that would look like. So here's a figure. In the center you have your main tornado, right? But kind of we have 1, 2, 3. Looks like we have an assortment of 3 kind of, hi Ashley. We kind of have an assortment of 3 sort of kind of sucky-uppy things, suction vortices. So in this class, a little bit ago, we talked about those the downburst and the microburst associated with the precipitation of thunderstorm cloud. Well, those would be like straight line winds, okay? And this is actually curvy winds. This looks like a deja vu sign. So it's tricky. They're still gathering information. Don't you love it when you take a science class? Well, to me, we should be gathering information in everything still, right? So, but if you're like one of these storm chasers, can you imagine paying somebody to drive you around and chase this thing? I don't know. You have more time and money than I've got, right? Yeah, I wish you could. But you're looking for strong updraft, and the reason it should be strong is the air is very unstable. We've talked a lot in here. Why would air be unstable? Kind of the same reason that warm air rises in your house. Okay, and or if you have water vapor in there, the water vapor condenses and makes it warmer, and so then, okay, so warm, moist air. The other thing is we talked about wind shear. The other day we talked about wind shear is basically you're changing either speed as you go up in elevation or you're changing direction. So it's kind of twisting air. So strong upper level winds is a type of wind shear. Yesterday, and nothing much became of it, but did you guys see how fast the clouds were moving? Like about 4 or 5 p.m.? You're like, dude.
The wind was crazy. It almost knocked me off my feet when I was getting gas. Not joking. I was like,
Yeah. It was like dangerous.
yeah, it was crazy.
You know?
I saw a tree down on the house on my way here on Time Street.
Oh, man. Yeah, because you figure those trees are used to, normal conditions. And so that's how they've grown. When you get those winds, sustained winds almost, or gust winds. So TS, remember, stands for thunderstorm. And if you have 100 thunderstorms, in general, you only have 1 tornado. So, I know. So wind shear, we said one type of wind shear is basically going up in elevation, your wind gets strong quickly. That's kind of what these blue arrows are showing you. So just picture that kind of scenario, wind shear, and then also picture basically underneath that chunk of air that's getting kind of rolled like a hot dog, think of basically some sort of uplifting going on. It may be convective uplifting, it could be frontal uplifting, but if you could get that rolling air to lift up, then you can get what's called a mesocyclone. So a mesocyclone basically within your thunderstorm cloud. And when I showed you a supercell, okay, we talked about basically that updraft wasn't straight, it was rotating. And that actually, to me, this is like a supercell. So that rotation does some interesting things, the updraft and the downdraft. We say the updraft wraps around the downdraft. So here's a little figure of you can kind of see, it looks pretty much invisible, but right here, you can see kind of the dust being thrown up.
And that cumulonimbus cloud is tilted.
Yeah, the cumulonimbus cloud, it does look tilted. Here it goes. So sometimes, and I'm going to bring us a picture, like just a Google search of wall clouds. But sometimes you will, and I don't know if it's more times than not, if this is kind of the base of my cloud, and I can't see it over here, that my base kind of continues, okay? Sometimes you can have what's called a wall cloud drop down from the base of your cumulonimbus cloud. So you kind of have to picture that, and it's not drawn to scale, because like up here we have, overshooting tops and everything like that. But just focusing on the base of the cumulonimbus cloud, that would be a wall cloud. So let's see what Google shows us. It's a coming. It's taunting me. Your computer is slow. Okay, so just on the internet, searching for the term wall cloud, I wanted some other figures to show you. So let's kind of look at a few of them. To me, this looks better than the figure that I got from your textbook. So can you kind of see this little kind of chunk extending down? Okay, this would be the base. Okay, and this it kind of jets out like this. And then what you're looking for is some sort of thing to drop down. Think of kind of that wall cloud as being connected to that rotation, the mesocyclone in your cumulonimbus cloud, the updraft. Let's look at another one. Or not. Scary looking thing.
Yeah. Very
So like when the National Weather Service puts on those trainings for severe weather, they will tell you to look for the wall cloud. And this one's a good one because you can almost kind of see the swirls in it, yeah. And it should be, if you're looking down, it should be going counterclockwise on that low. Kind of a different looking wall cloud. The other thing they'll tell you is that in training, they'll say sometimes you'll see something kind of drop down from the base. Yeah, and it goes by the name of scud, and it's just kind of throwing off this sort of thing. But if you see rotation, they do. They definitely can. This one's kind of showing you the diagram. Kind of the wall cloud is here, and the tornado is there. Let's get this one down. That one is wild. It's like beam me up, right?
It's like glowing from the inside.
What's it?
It looks like it's like glowing.
It does look like it's glowing. That one is creepy. I grant you. Okay, so those are wall clouds, kind of some better pictures of wall clouds. So to me, it doesn't say it, but this could actually be a supercell. Looks kind of to me like it. We're not focusing on the kind of the rotating updraft or the downdraft. But it's got some features about it that we talked about before. Notice the anvil, and I like what Autumn said. Basically, notice it can have kind of two flattened out places, but the anvil is kind of longer. Okay, that leads to the direction of motion. We talked about overshooting tops, and I know on this figure it's called some penetrating tops, but that's the same thing as overshooting tops. And I like this figure because it says where are they overshooting into? They're overshooting into the stratosphere. And I got a picture yesterday of mammatus clouds, what looked like mammatus clouds to me. I mean, there was no anvil to be, but they just remind me of mammatus clouds. So remember, anytime you see precipitation, I'm hoping you guys think downdraft. So this is the mature stage of the cumulonimbus cloud. And then we've been talking lastly in this part about tornadoes. So, they're kind of trying to show a wall cloud right here. That last figure that we looked at a minute ago, it kind of said that you can have this tail thing on the wall cloud. Looks like a mini anvil kind of. So I think that's about it for that one. Okay, so tornadoes, right? I'm going to show you a map of the world here in a minute, and you're going to see all these red dots over North America. Okay, no red dots. I mean, we get hit more than our fair share. And this where it talks about CP and MT, that was in the last unit of material. CP is continental polar, right? And MT is maritime tropical. So basically you can have a cold front lifting up that warm, moist air, and that is good for giving you supercells and or thunderstorms and or tornadoes. So I'm going to show you a site on the internet here in a minute, and it's going to show you the Tornado Alley. Now, Tornado Alley just means there's a lot of tornadoes there. So, and if you're like me, oops, that's what I was showing you. If you're like me, I'll go this way. I used to always, and I still do, get a little confused about Tornado Alley. Where is it? If someone, how would you guys describe Tornado Alley? If somebody asked you where Tornado Alley is.
Like through Oklahoma area.
Yeah, kind of through the Oklahoma area, Kansas. It's hard to describe. Yeah, someplace flat, someplace where those continental polar and the maritime tropical air masses can meet. Exactly. So in two different colors, what this article does, and I think I posted this on the Twitter feed a few days ago. The dark color is the old, Tornado Alley, and then kind of the lighter color orange is the new Tornado Alley. So, and of course, if you look at this, what we're most concerned about is us, right? So you can kind of see we are here-ish, right? Kind of the new Tornado Alley. Let's see.
So you're saying that from continental polar and maritime tropical, are they also in the summer because of the dry line from continental tropical? and
They can't,
maritime
yeah,
tropical?
yeah,
Maybe
that was
dry
the,
line?
right. The dry line would not be continental polar, it would be continental tropical, right, and maritime tropical. So that was just kind of a broad statement. Kind of with that statement, not the dry lines that get in the summertime, but kind of with that statement of continental polar coming down from Canada, it's these it's our Rockies and our Appalachian Mountains that kind of guide those two to clash. So if we didn't have mountain ranges on either side of our continent, things might be a little bit different. It's kind of the way I think of it. So here is just to kind of show you how we get hammered more than anybody else. Yeah. It's like, what's Mother Nature got against us sort of thing.
Just have all the right
Okay.
conditions.
Yeah. Australia, not only though, they've got a few over there. So focusing kind of on the United States, you can see this looks like a climatogram kind of where it starts with January, ends with December. And there about July is in general, about June is kind of our peak tornado season. So this is a map of Illinois, and each one of those segments is actually a tornado. And the length of the arrow, the segment, shows you how long it lasted. Okay. The colors are blue and red. Blue means that it didn't hit the ground yet, or was funnel cloud basically, and red means it was a tornado on the ground. Look at this one right here, tri-state tornado. They're like, dude, really?
That one was 1925.
I think so. And what direction are they mostly coming from? Doesn't it look like they're kind of,
Go to the northeast.
yeah, kind of starting from the southwest to the northeast. There are some exceptions, but. So here is let's see if it works for us, a website that I think is kind of cool. They basically broken out by county, okay? Broken out by county, here's the tornadoes. So it's going to show you Des Moines County first. And I can't remember, it's like what time frame it is. So in Des Moines County, when this project was begun, 1963 to 2011, you can see the tornadoes. You can see the number of injuries, like there's only no injuries except for June 29th, 83, 27 injured. The F scale right there, that's kind of important. You guys would tell me that 5's the highest, right? So you can kind of get a sense for what they are. So let's look at Lee County. And this one also is posted. Oh, there it is. Yep. And you have more than Des Moines County in general. Okay. I just thought that was kind of interesting. Kind of reminds me of those, if you've done much with genealogy, they have people out there that actually are combing the cemeteries and writing down stuff for people to, I think that's kind of neat. This kind of reminds me of. All right. So I thought, like I think I told you, we'd kind of visit the Parkersburg tornado. I have a short video to show you, and then kind of some miscellaneous pictures of the devastation afterward. Pair of figures from your textbook. Notice that actually in like Arkansas and Missouri and Illinois a little bit, but it almost looks like there are kind of two seasons. To me, it's hard for me to imagine that clear out here in October, November, December, you know, actually you have the possibility of seeing tornadoes. You know. Okay, so those crazy tornadic winds, right? They can do some strange things. They can take something that's pretty weak and drive it through something that's solid, like straw through a wooden plank. Relocating something heavy, like a airplane wing, 10 miles. If you're not familiar with what a gravity wagon is, I looked it up, and I'm not going to bring this, but they're those, like during harvest season, they're the kind of that farmers tow them with their grain. Okay, relocating it a mile down the road. Relocating a mattress 40 miles, and this was that check that went downwind, or not downwind, it was carried by a tornado 223 miles. I know. So here are kind of some strange things that tornadic winds can do. And what I did was I went to Google and I kind of just typed in strange things that tornadoes do for images, and this is what it looks like. So on Monday when we talk about hurricanes, we're going to see that, yeah, hurricanes are more like flat. Like actually we saw the Parkersburg tornado and the Joplin tornado too, just kind of flatten things. But tornadoes can be kind of selective almost, it seems like. So, let's see, where did it go? Yeah, you saw that McDonald's one? That's one of my favorite. Kind of catches your eye. This one? Tornado did that. You're like, really? Tornado. Tornado.
Don't they tell you if you're in a basement to get your shower? I'm not sure that works.
Yeah, yeah. And this, if you read the caption, it says damage included a sock being driven through the hood of a Toyota pickup truck. You're like, really? That's pretty. Almost looks photoshopped.
Yeah.
But, so you kind of get the idea. I think this one's neat. Tornado. Notice these structures look okay,
Yeah.
but the whole tree, and the power line wasn't brought down, but the tree was located in the, it's just weird.
Is that because of those suction?
Could be, the
vortices?
suction vortices that kind of do this sort of randomness. It could be.
That fork stuck in.
You're like, it is crazy. So we kind of talked about tornado outbreaks. Basically, it just means that at least 6 tornadoes came from the same weather system. And here are some kind of stats on tornado outbreaks. In 1925, there was that's the tri-state tornadic outbreak. Killed 700 people. Then in 74, there was 148 tornadoes on the same day with the same air weather system. 148 tornadoes. Notice that 30 of those 148 were the strongest, F4s or F5s. Like, dang. 1999, outbreak went through Oklahoma, Kansas, Texas, and Tennessee. And actually that 1999 one is here. Each color is a different tornado or a different storm system. So Yeah, categorizing them, the F5 is the strongest. So somebody asked me last night, why did they enhance the Fujita scale? F stands for Fujita, so F5 is Fujita. Now EF is enhanced Fujita scale, and that's what we're using now. And I'm not sure why we've gone to enhanced Fujita scale. But notice that 5 is the highest, and it does have a 0. When we go to categorize hurricanes on Monday, we're going to see that there isn't any 0. It starts at 1, goes to 5. 5 is the strongest hurricane. But, and you're going to see this graphed here in a minute, but about 70% of tornadoes are the weakest. And the weakest, the F0 to F1. Moderate ones are 30%, and the strongest tornadoes, the F4, F5, are only 2% of the tornadoes. But with that in mind, these, we'll look at the statistics here in a minute. So what they do, it's kind of like I think of an insurance adjuster. Basically, after the fact, they go out and they look at the area and they look at the damage. So that's that last column. Then they kind of backtrack to what wind that must have been estimated at, and then they assign it a category. So the red bar is actually how many tornadoes there are of that type. So starting with the most mild ones, we said almost 70% tornadoes are that. And then the orange bar is how many people die from that type of tornado. So that is the weakest tornadoes. This is the moderate tornadoes. Notice there are fewer, okay, almost 30%, but there are definitely more deaths. Okay, but here's the deal. About 2% of tornadoes, only 2% are F4, F5s, but look at all of the deaths that are associated with them. So that's why people get excited on, when if it is an F4, F5, like, oh man. So something you mentioned, the Moore, Oklahoma, and in Oklahoma, honestly, that is the folks who give us our watches. So yesterday when we had a tornado watch, they basically said, and they're National Weather Service people, they're called the Storm Prediction Center. Okay, they basically said, looking at the atmosphere as a whole, you look like you might have some issues there. And they specifically said tornadoes, so tornado watch was issued by these folks. And what's ironic is that they do definitely, Oklahoma City or Oklahoma, get their fair share of tornadoes coming through. So they issue our watches. And then our warnings, as some of you guys know, warnings are scarier than watches. So warning means that they've seen it, In the case of tornado, it means they've seen a tornado. So warnings are more local. So they're put out by the local National Weather Service, which might be Quad Cities and might be... who's the other National Weather Service, you guys? Is it
around Springfield?
Springfield might be for you guys, too. So there's these things called the convective outlooks, and actually the folks in Norman, Oklahoma, the Storm Prediction Center people, they put out these convective outlooks. And they're kind of like a blog, I think. Basically, sometimes they have other meteorologists chime in with their information, but it's like convective means lifting up, unstable. So that's kind of what's going on. So I've got some screenshots from your textbook, and then I think we have time. I just want to quickly kind of look at the current convective outlook. So typically what the convective outlook, first off, the convective outlook has day 1, which is today, day 2, 2 days from now, day 3 usually, the convective outlook. And what they'll do is kind of have this, you kind of see the bullseye, so the red means high probability, moderate for the purple, green is the slight, okay, kind of like that. And they're broken out, that one's general severe weather, this one is the possibility of having tornadoes, okay. This one is damaging winds, and then this one is hail. So they're slightly different based upon their knowledge of what the atmosphere is doing. It's called a convective outlook. So, this semester I've been doing more with, a little bit more with the not AccuWeather, what's the other one?
Wonderground.
Yeah, Wonderground, exactly. Oops, that's what I wanted. So, like, I already pulled up, if you go to Weather Underground, it looks something like this. And if you went to the home page, looks something like hopefully this. Because I wanted to show you where you get to it. A better place, or not a better place, but another place I don't think it's as pretty to get the convective outlook is actually from the National Weather Service site. I just don't think it's as pretty. So this is Weather Underground, and at the top there are some tabs, and one of the tabs is severe weather. So if you click here, under severe weather, you could go down and have those convective outlooks. So this is day one today. Notice that this is actually, I think it's just general severe weather. So to me, to understand a convective outlook, I always have to look at that key down here. So just marginal, like that darker color, they have a marginal chance of generally having unstable weather. And so you have to look at the color code. But that's where you find it. So when I looked, even day 3, it didn't look too bad. So we only have one slide left, right? Is he right? Oh, we have several slides left.
Quite a few.
Okay. Well, we are out of time, girls and boys. So this actually won't be due on Monday. It'll be due on Wednesday. But you have enough to do it if you want to, but I won't collect it till Wednesday. And we're out of time. But we will definitely get through, finish up this chapter on Monday.